This is the Flip 450 with the APM 2.6 flight controller. You have your 12-volt camera. Remember, when you buy the receiver monitor, to view the image, this transmits on NTSC, not in PAL. You have your OSD that transmits the data to the monitor. Sunny Sky Motors 30 amp speed controller with Simon K firmware, 600 milliwatt transmitter, 5.8 gigahertz. The APM is mounted on dampeners. Here's the power module. That grabs the amps and the volts data. GPS module. Show you the assignments on the transmitter, and then we'll go for a flight. When you first turn it on, all buttons away from you or in this direction, away from you or up. Make sure all the buttons are away from you. This first switch here has a 3-position switch. Mode 1, which is all the way away from you, it's stabilized mode. This is altitude mode. It holds the altitude. This is position hold. This is what you most use, and you will fly in position hold. This is a circle mode. The copter will do circles in a predetermined radius and speed with a camera facing forward. This 3-position switch displays the data on the monitor. This is off, so you get a clear picture with no letters on the actual monitor. This puts basic information on the monitor, and this just adds additional information on the monitor. This right here is your timer. You flick it up, the timer starts. You flick it down, it resets. This right here, very, very important, this long switch here, this is the return to launch. You flick this switch down and the copter will return back to its original takeoff position. It will land and it will turn the motors off. So if you're not sure where the quadcopter is, or you feel like you're in trouble, it's out of sight, or you don't have control over it, just flick the switch and it will come back and land. This right here is the auto switch for waypoint navigation, which I programmed into the transmitter via the mission planner. You can navigate to a certain position, altitude and position in the sky. You flick this button up and you hold it, it will record waypoint 1. You flick it up again in another position and it will record it. You go to a third position and you can go to you can go 12, 20, 30 different waypoints, and it will record it every time you flick this up and you hold it for 2 seconds. Then you flick this switch down and it will navigate to all these different waypoints with the longitude, latitude, and altitude on which you recorded. When it gets to the end, it'll just stay and hover at the last waypoint. This right here is the virtual fence. When this is up, a virtual fence is erected and the copter is not allowed to trespass, say, 150 feet in altitude and 250 feet radius from its launch position. That's what presently it's set up in the mission planner. So all the switches away from you. excuse that. And here's the monitor. It is not included, but show you this right here is in the up position, so there is no data. When I flick this to the middle position, flicking to middle position now, you can see the data, and flick it again, additional data. You have here, you have altitude, you have the flight mode, you have the number of satellites, voltage, amps, battery, percentage, course. This is the speed over ground. You have your degrees and which way the copter is actually facing. This is the percentage of throttle. This is your timer. And this right here is your distance from home in feet. And this arrow points where home direction is once you are in flight. So now with all the sticks away from you, you can take off either in stabilized mode, in position, in altitude hold, or in position hold, which is altitude and position hold. Now for you to take off in position hold, you have to make sure that this satellite image icon is not blinking, which means that not only it has acquired enough satellites, but also the HDOP, the dilution of precision of the GPS, is very accurate. And now you can take off in position hold. The flight controller does a number of about a dozen checks before you take off to make sure that everything is working fine. So now I am in position hold, and I am going to put the stick to the bottom right, hold it for a few seconds. Now remember, this throttle is spring loaded for your safety, so that way when it's in mid position it will hold the altitude. So come back slowly, and I let go, and it is hovering, holding its position. I am not touching the transmitter in any way. Okay, so basically I'm going to be flying with one hand because I have a camera on the other hand. Let's do a, I'm going to go raise to about 60 feet. Let's do a circle. I'm going to flick the switch that you saw me previously show you that was circle mode. Flicking the switch now. Try to zoom in, see if we can get focus. There it is, doing circles, keeping the camera in the center. I am going to flick the switch off now, and it will hold its position. All right, there we go. Okay, now let's do a return to launch. Return to launch, I flick the switch, it's going to turn, it's going to face the direction of the launch, it's going to come, land, and turn the propellers off. Flicking the switch now. I'm not touching the transmitter right now. Just hanging on my neck. And it turned the motors off. And it will do the same for a low battery. Right now it's programmed for 10.3. Anything under 10.3, it will automatically return to launch. And if the fence is bridged horizontally, it will come back and return to launch. If you want to take off again, I am going to put the switch mode, which I showed you, which is the stabilize, elevation, and position hold switch, back to position, back to stabilize, and turn off the return to launch. Now, it is drifting away because I have it in stabilize mode. As soon as I flick it to position hold, it's actually holding the position. That's going out higher. I'm flying with one hand. Okay, let's put it about there. And all right, let's see. Let's show you the monitor. It's holding position. Let's see where. Can't get a clear shot of that. Battery at 76, 11.2 volts, 17 amps, 10 satellites. There's the position hold. It will actually read out 23 feet in altitude. Now let's climb. Let's take it high. Now not towards the sun. Drop in and let's go. There we go. And let's climb. Zooming in. If I zoom out, this is actually where it is. And let's see how high we are. We are at about 125 feet up, holding the position and holding the altitude. I'm going to rotate the tail. Apologize for the glare. Rotating. Okay, let's do a return to launch from this altitude. It turns, flies back to its launch location, even at that altitude, turns, faces the direction that it originally took off from, and descends at a specific rate of descent up to about 10 feet. Then it descends slowly the rest of the way to land. There it is. The motors have been turned off. And how can you tell if it's running well, running efficient? One of the things you measure is see if the motors are hot. This is not even It's actually not even lukewarm. Battery lukewarm. Speed controller, nothing. It's not even getting lukewarm. This is one of the indications that you have a very efficient working quadcopter as far as the choice of speed controllers, motor, and weight ratio. And this is it for this video. Any questions, please contact me. Thank you.